Hello, we're going to talk for a minute about parallel lines and the special angles that they create. This is a very helpful set of rules that I think you will find quite useful. So here I have two parallel lines, and I'm going to cut them with the transversal. Usually they label the transversal as a T. And you can see that when I take these parallel lines and I cut them with the transversal, I make a whole bunch of angles here. See, 1, 2, 3, 4, 5, 6, 7, 8, right? Those different angles. Well, some of those angles have special relationships to each other. And so the first type of angle that I'd like to talk to you about are called the alternate interior angles. The alternate interior angles. And the alternate interior angles, well, alternate means one side and then the other side, right? Like we're taking turns. And interior means inside. So we're going to look at the angles that are inside the two parallel lines. Here's the two parallel lines. Parallel, parallel. Sometimes with parallel lines, when we know that they're parallel, we mark them like this with like two little arrows going the same direction. Okay, so we have these parallel lines here. There you go. Now it doesn't look like a line thing. Anyway, so we have these two alternate interior angles, which are inside these two lines. They're interior, and they are alternate, so they're on alternate sides. So this angle right here and this angle right there make a pair of alternate interior angles. And then this right here and this right here is another set of alternate interior angles, right? They are both alternate, meaning on opposite sides of the transversal, and interior, meaning inside, if you will, the parallel lines. Now, the cool thing about alternate interior angles is that if two lines are parallel and are cut by a transversal, the alternate interior angles are congruent. So this angle right here is congruent to this angle. And this orange angle is congruent to that orange angle. That is one set of special angles that are created because we have parallel lines being cut by a transversal. It doesn't work if you just have any old lines cut by a transversal. It only works if they're parallel. All right, let's draw another picture for ourselves, just so that we don't keep getting messed up. This time I'll turn my transversal that way, just because, I want to be fancy. Okay, so now we have these two parallel lines. I'll mark them as parallel. And this time I want to show you corresponding angles. Corresponding angles. You could think of corresponding angles as meaning kind of they line up with each other. So let's take a look at this diagram. So I have my transversal coming here, and I have one of my parallel lines here. These angles on the inside are already taken care of by our alternate interior angle theorem. So we're not going to worry about those anymore. We're going to worry about these. And we have this one, which is above the line and on the, what would that be, the left side of the transversal. So if I go down here and I go above this line, still on the left side of the transversal, those are corresponding angles. There's another set of corresponding angles. I can go to this line and go below this line, and then I can go to my other parallel line and go below it, staying on the same side of the transversal, And those are corresponding angles. Okay? I can also do the same thing on this side of the transversal. So here I can have above the parallel line on the right side of the transversal, and that is going to line up with this angle. These are corresponding angles. The orange ones are corresponding because this is above this parallel line and still on the right side of the transversal. And then finally, I need a new color. Let's go with, okay. And so on this side of the equation, or on this side of the line, I have one more. Oh boy, I got a lot of arcs there, don't I? 1, 2, 3, 4. Again, below the parallel line on the right-hand side of the transversal, below the parallel line on the right-hand side of the transversal. Those are called corresponding angles. So you would say that this angle is corresponds with this angle, and the pink angle corresponds with the pink angle, and the orange angle corresponds with the orange angle. And you will be happy to know that there is a very helpful theorem for us that says if two lines are parallel and are cut by a transversal, the corresponding angles are congruent. Isn't that cool? Okay, so now if we know that we have parallel lines, we are in great shape. And just so you know, here's a little hint for something else that you're going to learn in the chapter. If you can prove that these angles are congruent, that means that you know the lines are parallel. So the converse of these theorems also works, which is pretty neato. Okay, I hope that now you understand alternate interior angles and corresponding angles.